Scientists propose plan to determine if Planet 9 is a primordial black hole. Date: July 12, 2020. Source: Center for Astrophysics, Harvard and Smithsonian, CFA. Summary: Scientists have developed a new method to find black holes in the outer solar system, and along with it, determine once and for all the true nature of the hypothesized Planet 9. Scientists at Harvard University and the Black Hole Initiative, BHI, have developed a new method to find black holes in the outer solar system, and along with it, determine once and for all the true nature of the hypothesized Planet 9. The paper, accepted to the Astrophysical Journal Letters, highlights the ability of the Future Legacy Survey of Space and Time, LSST, mission to observe accretion flares, the presence of which could prove or rule out Planet 9 as a black hole. PBH 1. Introduction. As of this year, two gravitational anomalies of similar mass, but very different origins remain to be explained. First, there is a growing body of observational anomalies connected to the orbits of trans-Neptunian objects, TNOs, 1 to 3. 1 to 3. These observations have been taken as evidence of a new ninth planet in our solar system, called Planet 9, P9, with mass M9515m, and orbiting around the Sun at a distance of 301,000 AU. 4. Second, there is set of gravitational anomalies recently observed by the Optical Gravitational Lensing Experiment, OGLE. OGLE reported an excess of 6 ultra-short microlensing events, with cross-ING times of 0.10.3 days. 5. The lensing objects are located towards the galactic bulge, roughly 8 kpc away. These events correspond to lensing by objects of mass M0.5m20m6, and could be interpreted as an unexpected population of free-floating planets, FFPs, or as primordial black holes, PBHs. It is remarkable that these two anomalies correspond to a similar mass scale. Perhaps the most natural explanation is that they are caused by the existence of an unknown population of planets, i.e. the OGLE anomaly should be interpreted as due to FFPs denser than the local star population, 7, and P9 might be one of those planets that have been captured by the solar system. This would imply that our models for planet formation may need to be updated to account for this new population of FFPs, but the current program to hunt for P9 would go unchanged. We focus on a more exciting possibility. If the OGLE events are due to a population of PBHs, then it is possible that the orbital anomalies of TNOs are also due to one of these PBHs that was captured by the solar system. In this paper, we argue that this scenario is not unreasonable, and discuss the observable implications. We estimate the probability of capture of a PBH by the solar system, highlight that the observational constraints differ significantly between planets and PBHs, and point out that the dark matter, DM, microhalo, which generically forms around such a PBH, can lead to its discovery. M, which we summarize in Table I. Crowlensing events in the 0m, which we summarize in Table I. Annihilation signals from the dark matter microhalo around the PBH. 2 anomalies. While the structure of the solar system to semi-major axis of 100 AU is well explained, for A250 AU there are TNO populations whose orbits cannot be readily understood. Observations of TNOs, objects with A30 AU, and extreme TNOs, ETNOs, with A250 AU exhibit the following anomalies. Unexpected clustering in ETNO orbits, 2, 3, 2, the existence of high perihelia, Q70 AU, TNOs, such as Sedna, collectively called sednoids, 1, 2, 8. 3. TNOs moving roughly perpendicularly to the planetary plane, with inclination IN 50, 9 to 11. An excellent review of TNO anomalies is given in 4. Simulations and analytic arguments indicate that these observations are at odds with the predicted dynamics, assuming only the known giant planets. For instance, any coincidence of initial orbits of ETNOs will disperse under evolution, on a timescale of a 10 to 100 million years, 12, and solar system simulations imply inclinations are typically bounded by I. 40, 13, 14. Notably, all of the TNO anomalies can be simultaneously explained by a new gravitational source in the outer solar system. From observations of TNO dynamics, one can infer the likely mass and orbit of this hypothetical source, referred to as Planet 9. Simulations of TNOs have identified a number of characteristic benchmark scenarios for a new gravitational source of mass 5m and 10m.
Here's the benchmarks for the suspected Planet 9. If it's 5 masses of the Earth, then it would be 450 AU to 500 AU. And if it's a 10 mass of the Earth or Sun, I'm not sure which they're using. I think they're using the Earth. It's 700 AU or 980 AU.
Primordial black hole is a remnant from the Big Bang that came from a very dense region that almost instantly collapsed into a small black hole, right? If we do our searches, and it turns out that there is a planet in the outer solar system, this would be an absolutely incredible discovery. Such a strange planet on such an odd orbit, it would really change our understanding of the history of the solar system.
But if it is proven that this is a black hole in our own outer solar system,
this is completely mind-blowing. And the fact that this not only would change our understanding of solar system physics, but it also gives us a new window into astrophysics, into early universe cosmology, and potentially into the fundamentals of particle physics.
whether it's a planet, a black hole, or something else entirely, one thing is for sure. When we do find the source of this mysterious gravitational...
And this is a diagram of Planet 9 a couple of years ago. And this is one of 3 stars circling the Milky Way. This is Sagittarius A, the center blue dot of the Milky Way. And see how the stars seem to go in different directions like this? We're seeing the same thing with this odd projection of the way the planets or planetoids are circling this area of Planet 9. And so I just thought I'd show you a simulation of Sagittarius A just so you could see how the way the stars rotate around it. It's very interesting. they said that they suspect it's in the direction of the galactic bulge, closest to the galactic bulge. But from this picture, I would say it was in the area where thing is missing. But I could be wrong, so I'm just saying. Notice this gap right here. But here's Neptune, Uranus, and Jupiter and Saturn here. And this is the known Kuiper belts beyond Neptune are in the scale of AU. So this is the AU scale of 20 AU and 40 AU. So 40 AU would be here to here. So out here to the edge of the blue is 40 AU. So Neptune is probably 30 AU and Uranus is 20 AU, etc., etc. So it would be something about out to here. They said at least 50 AU, anywhere from 20 to 50 AU, so it could be anywhere in this range here. So if it's anywhere in this range, it could be right here, where everything's missing, but that's just my opinion. That's not fact. And then the other thing I want to show you was the thing I've been capturing ever since 2017 in the morning sky is this anomaly that looks like it could be a grapefruit-size small black hole because it swirls around in the same pattern as the black hole. This is what it looks like in relation to the sun. So, but it could be, farther out. It could be behind the sun. At 30 AU, to 40, 30 to 40 to 50 AU, it could be way out, It just looks that way, And here it is up close. We see this starting from November to December through to January almost. I think it quit on December 31st or so. So if I start seeing it earlier and earlier every year, then it could mean that it's getting closer or bigger, or or the solar system might be going past it and just going to completely pass by it. So we don't know anything about that.
T's 1905 and Uranus is acting funny. Its orbit appears to be disturbed by some gravitational. Astronomers rule out Neptune as the culprit. Luckily for science, a millionaire Bostonian named Percival Lowell, of Lowell Observatory fame, has another hypothesis, in the form of a faraway, mysterious planet he dubs Planet X, which he speculates is the cause of the gravitational tug. Lowell makes it his life's mission to find the enigmatic solar body, but, alas, dies in 19... Lowell's widow, and the observatory over her husband's legacy. The search is put on hiatus for a decade. Finally, Clyde Tombaugh, a bright-eyed, 23-year-old researcher, is put on the tedious job, which requires him to take paired images of the night sky days apart, and compare them to determine whether any objects have shifted position. On February 18, 1930, after months of the painstaking work, he notices a shift. There, held between his humble mortal hands, is Lowell's ninth planet.
And here's a picture that Tombaugh made. This is 2012, 13, 14, 15, 16, 2017, 2018, 2019, 2020 at Venus, 2021 on Earth orbit, 2022 on Mars orbit. See, this is the story about when Lowell discovered a planet. More pictures coming up. And this is a NASA image of where they think that if there was a planet X, this is where it would be.